Hey everybody, welcome to day 4, this last day of week 1. Already a fifth of the way through it. Couple of things. One is that, let me share my screen real quick. You all should be checking out these pages right here, okay? I've had a lot of people do, I think they're just clicking on the right on this little thing right here, but in reality, instead of clicking right here, click on the days. All right, this is where all the information is. All right, this tells you like step by step what you need to be doing. Okay, so really click on these days. This is day 1.4, so you're probably watching this video right here. And what we're talking about today is we're taking these equations, these graphs that we learned how to do on Desmos last time, and we're just going to be exploring the equations a little bit and the descriptions, the relationships that these represent. Okay, so this right here is the presentation that I'll be presenting from. You can open it up as well and follow along, or you can just watch this. All right, so this is basically what? That's not where I wanted it. Ignore all of that. My apologies. So last time we talked about Desmos and how Desmos can give you these 4 basic shapes. So you put in your points, you see what shape it creates, and then that gives you a name: linear, quadratic, inverse, horizontal. But on the left-hand side, you'll notice that there's also these equations. Okay, this red corresponds with this red, this blue with this blue, this green with this green, and this purple with this purple. Okay, and when you're changing the C value, you're actually changing the value that's in each of these C's. So these 4 relationships, linear, quadratic, inverse, and horizontal, have 4 different basic equations. Okay, so these equations are kind of basic, all right, in terms of like, you're not always gonna have y and x. For instance, you might have distance is equal to velocity times time. But what's gonna be in common about this is that you have one variable over here and 2 variables over here, okay? So this right here, you might see it a few different ways. So here are the 4 different equations, and we're going to talk about some characteristics with these equations. Okay, so linear relationship, this one right here. Basically, whenever you see an equation, you'll see it that looks kind of like this: y equals cx, which is basically one variable on the left and 2 variables on the right. Or maybe it's a number in a variable on the right. So y equals mx, this is linear. Okay, or d equals vt, this is linear. You can tell because it's one kind of letter or number over here and then 2 things over here. Let's look at quadratic. With quadratic, you'll always see a squared sign. So anytime you see these equations and has a squared sign, you know it's going to be a quadratic relationship. Inverse is whenever you see a division sign. Okay, so these are all examples of inverse relationships because it has a division in there. And then horizontal, oh, I hate it when this thing blocks it, is basically when you see that it's going to have just one thing on the left and one thing on the right. Okay, so the first thing that I would like you to do is you can look at a graph and you can guess the equation, okay? Or I can give you the equation and you can tell me what relationship it is. So if I tell you this, here's the equation of something in physics, you automatically know like, oh, hey, here's a squared, it's gonna be quadratic. Why? Because it has a squared sign. This one right here, oh, it has a division sign, so it's gonna be inverse. This one right here only has one thing on the left and one thing on the right. That means it's going to be horizontal. And this one right here has one thing on the left and 2 things on the right, so it's going to be linear. So being able to look at these different equations and tell what relationship is super important, okay? We can also learn one more thing about it, okay? And I'm actually going to open up this graph real quick to kind of illustrate it. So it's to describe these relationships. So here are these that I was talking about, and moving the C changes the shape of them. But look at, red is going to be my linear, quadratic, inverse, horizontal, okay? But I want to show you some cool things about this graph. So let's say I am going to look at linear. So linear is the red one, okay? So I'm just going to look at the red line real quick, okay? And I'm going to set this to 2. Okay, look at this. I can click on this graph and I can say, hey, look at here. At this point, the x value, the independent variable, is 2, and the dependent variable is 4 right here. Now I can click elsewhere on the graph and see, oh, right here. But what I'm going to do for this next little slide is I'm always going to double the independent variable. So if I start right here with the independent variable at 2 and I double it, it'd be at 4, it goes up to 8. So it starts from 2, 4, it goes up to 4, 8. So if I double the independent variable on a linear graph, 2 to 4, then the dependent variable also doubles. It goes from 4 to 8. Okay, so when I double the linear relationship, I double the independent variable, the dependent variable doubles as well. Now let's look at quadratic. Okay, quadratic is this one right here, and I'm going to start with this point right here, 1, 2. Okay, so when my independent variable is 1, my dependent variable is 2. So now I'm going to double my independent variable. So it's going to go from 1 right here to 2. But now look at my dependent variable is at 8. So it actually quadrupled, okay? It quadrupled. So in a quadratic relationship, when I double the independent variable, the dependent variable quadruples. In other words, it means times by 4. Now let's look at an inverse. Inverse is this one right here. I'm going to start with this one right here. Bam. Right here is at 1. So if my independent variable is at 1, my dependent variable is at 2. But now I'm going to go to my independent variable is twice as high, 1, but look at this. Sorry, it's 2. My dependent variable is 1, so it went down in half. Okay, so in an inverse relationship, when I double the independent variable, the dependent variable decreases in half. And then the last one is horizontal. In the horizontal relationship, if I go from 1 to 2, look, it doesn't change. It's always the same, okay? So in a horizontal relationship, when I double the independent variable, the dependent variable doesn't change. So this is something that ideally you can have kind of memorized, but you know what? I also put it on this main graphic. And in this main graphic, I put on Canvas, and it's something that I would have students put in their interactive notebooks and something that you can use on the test. So your homework problems tonight are basically dealing with this. Looking at the graph, giving you the equation, and tell me the relationship. Or if I give you this, you can sketch this and do this. Okay? That's all I have for you tonight. Have fun. I'm also going to post the unit review on Friday. So if you want to do the unit review over the weekend, you can be ready for the test, which will be on Monday. Talk to you later. I don't have anything else. Take it easy. Peace.